Now, today I am going to discuss about the topic Boolean algebra, which comes under the discrete structure theory and logic. I am Amit Kumar, assistant professor in IT department. I am going to tell about the uses of Boolean algebra, what is Boolean algebra, and what are the algebraic formulas of Boolean algebra, how to solve it, and K-map. Now, in the next slide, what is the introduction about the Boolean algebra? Boolean algebra is introduced by or developed by the George Boole in between 1815 to 1864. Okay, so from the scientist, English mathematician Boole, from the name of the Boole, Boolean algebra has introduced. So this name is Boole. So it is Boolean algebra. It is described as the Boolean of logic or an algebra of two variables, that is true or false. In the Boolean algebra, we are going to tell that the statement is true or false. We are not going to say that in between true or false. Okay, we are not discussing about the fuzzy set or fuzzy things. So we are going here the true values, two values, true or false. So this is telling about the Boolean algebra, and the term true and false is having the binary decision, means true means 1 and false means 0, and it can be understood by the computer or system, that the system is understanding only 0 and 1. Okay, so the Boolean algebra is going to saying that 0 and 1, so we are writing 0 and 1 true or false value in the Boolean algebra. What are the applications of the Boolean algebra? The Boolean algebra applications to perform the logical operations in the digital computer. What are the logical operations? We are going to discuss in this topic. So in the, as I have discussed that in digital computer, true is defined as 1 and false is defined as 0. We can say that high volt, low volt. In Boolean algebra is also a part of electronics. So we can say that the this is a high volt, low volt. As we are making the diagram like this, as we are making the diagram, so this is 0 and this is 0 and this is 1. So we are saying that this is high volt, this is low volt. Okay. Now the logical operations, as I have told you that I will discuss about the logical operation. So there are the three main logical operation: and, or, not. Okay, and is also called as a conjunction, or is called as a disjunction, and not is called as a complement, negation, you can tell it. And we have the sign also, and so and, or, not, we have the sign not. Okay, these are the signs of not. Okay, and this is the sign of and, this is the sign of or. Right, this way you can write it, plus, dot. Okay, so these are the signs for the and or not. Okay, so and operation, first we are discussing about the and operation. And operation perform the logical operation, and we can write it the multiplication, or we can denote as the dot. Right here I am going to discuss about that, and I am going to tell you that the element, how to define the element. Here is the formula 2 to the power n. To take the elements like this, 0 and 1, there are two elements, 0 and 1, there are two elements. So 2 to the power 2 equals to 4. We have to take 4. Okay, we are taking 4. Now how to point the values, that is discussed. How we are taking first time 0 means false, second time true, false, true, again true, true, false, 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 true, true. We are taking, so we are putting the values 0 and 1. In the Boolean we are taking 0 and 1, but in the logic we are taking at a true or false. We can make this diagram also true and false. I am going to draw that diagram. Okay, 0 1. Okay, like this, 0 0 0 0 1 0 1 0 0 1 1 1. Here is a multiplication, so you can put it 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1. So this is the basic rule. Now I am drawing this multiplication by the putting 0 as a false and 1 as a true. X, y and x dot y. Okay, false, false, then false, false, true, false, true, false, false, true, true, true. This is the logical multiplication which we have to understand it. Okay, I will draw all the diagram and or not like that. So this is the diagram: false, 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 true, false, true, false, false, true, 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 because this is the multiplication and operation. So we are writing, as I have discussed there in the previous and operation, dot also you can write here, plus also you can write. So these are the methods, these are the logical operations. You can show that you are performing AND operation, NOT operation, OR operation, NAND operation, XOR operation, anything we have the sign. Okay, now we have studied about the AND operation. Now we are studying, now we are looking about the OR operation. OR operation is performing logical addition. It performs logical multiplication. AND operation is performing logical multiplication, but this perform logical addition and it is denoted by the plus sign. Okay, so now the diagram, you can say that 0 0 0 0 1 1 1 0 1 1 1 1. Now you can add it: 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1. There you are asking that 1 plus 1 is 2. No, because this is the Boolean, so we are taking as a 0 and 1 only. So this is 1 plus 1 1. Now we are denoting as a true and false. False, false, false. You can add it: false, true, 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 false, true, 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 true. Okay, now this is the easy. Now NOT operation. NOT operation is showing that the logical negation, or you can say that it is denoted by the bar, dash, anything you can show it like this: x bar. You can say the complement, you can show x here, you can show that x dash. This is also, you can show that this is a NOT operation. Okay, we can say the complement. So the complement is 0, the complement of 0 is 1 and the complement of 1 is 0. We can say that x bar. What is the false of complement? True, and true of complement is false. This is the NOT operation. Here you can understand about the AND operation, logical AND, logical OR, logical NOT. Now what we are making over these are the truth tables. Okay, how we are, what is the truth table? Now we are going to discuss about it. Truth table is a table that contain all possible values of logical variables, statements in a Boolean expressions. Okay, what I have told you that 2 to the power n, what are the possible combination? There in the previous slide I have discussed you that what are the number of possible combination. Here it is number of possible 2 to the power n. That's why the number is and for n number of variables used in a Boolean expression. Like I have given you the example. We have 0 and 1. We have the number of variables is 2. So 2 to the power 2 is equals to 2 to the power 2 is equals to 4. If we have the 3 variables, 2 to the power 3 is equals to 8, and we will put in the truth table 8. So this is the 3 elements x, y and z. So we have the 3 variables, as I have discussed in the previous. We have the 3 variables. 2 to the power 3 is equals to 8. So you can say that the possible values is 8. 0, 1, 2, 3, 4, 5, 6, 7. These are the 8 possible values. So we are putting x, y, z as a 0, and we have to make the truth table of x, y plus z. So first we have to x dot y. So we have to find x dot y. X dot y means we have to logical multiply it. Means only 1 and 1 value having the 1, otherwise 0. Okay. So x and x dot y we are finding. We are taking these two values: 0 0 0, 0 1 0, 0 1 0, 0 1 0, 1 0 0, 1 0 0, 1 1 1, 1 1 1. So these two are 1. Now we are taking for z and f plus. So here we are taking the logical addition. So we have to add, and there where any value is containing 1, we are putting 1. So 0 0 0 1 0 1 0 0 0 1 0 1 0 0 0 1 0 1 0 1 1 1 1 1, and this is the truth table of x dot y plus z. Like this we have to make it, and you can draw the diagram 0 1 as a true false also for the logics. Now logic gates. As we have taken the logic operations, now we are taking as a logic gates. So the logic gates also have the 3 types: and, or, not. Okay, so we have to discuss about the AND gate, OR gate, or NOT gate, how they are going to perform it. Okay, so the gate is a digital circuit where operation 1 or more signals are produced in a single output. So in this means there are many operations or many operations or many signals or many circuits for that. So you have to make it, and you have to use in the logical diagram. So by the use of logic gates, and you can solve it. Now first is AND gate. As we have studied for the AND operation, so we are going to first learn the AND gate. The AND gate states that the AND gate is an electronic circuit that gives a high output. High output means 1. 1 means high output, and only if all inputs are high. That I have told you. As we have drawn the truth table of AND operation, so this is the truth table of AND operation: 0 0 0 0 1 0 1 0 0 1 1 1. So these are the high volts. So these are the high volts. So these values is going to be high, and this is the diagram of AND operation. We are taking A, B. This is the AND operation diagram. This is the AND operation diagram, and this is the output A and B. We are going to solve it, no problem. This is the OR operation. OR operation means OR gate is an electronic circuit that has a high output 1 if one or more of its inputs are high. It means it is saying that if any input having the high volt, we are taking as a high. Okay, and add operation 0 0 0 0 1 1 1 0 1 1 1 1. So this is the output, and this is the diagram of the OR gate AB. This is the diagram. A plus B, and we are taking the values A and B. Now NOT operation. NOT operation is saying that if you have the low volt, then you can change into the high volt, and if that is a high volt, you can change into the low volt. This is the, it is also called inverter. You can remember it. This is the important point. It is also called inverter. NOT gate is also called the inverter. This is the sign A dash. So this is the diagram of NOT operation, how this is going to be done. Now next topic is principle of duality. In the principle of duality, it is stating that the variables are unchanged, compounds are unchanged, but the OR operation is changed with AND, 1 is changed with 0. Okay, you can change the values, you can't change the values, but you can change the values of 0 to 1, AND to OR to AND. This is the principle of duality. So principle of duality states that in Boolean algebra, the duality of principle can be obtained by the interchanging AND with OR operation and replacing 0 by 1 and 1 by 0. Okay, so this is the example: x dot y plus z dash equals to, I am solving it, x dot y plus z. These are the variables. We can't change the variables, so we have to put only the variables. Okay, x, y, and z. Okay, now we are changing that, changing the complements also. So z dash changed to z, y, y dash. Okay, now dot is changed to plus, and plus is changed to dot. This is the principle of duality. Okay, we are changing the signs or complements. These are. Now we are discussing about the basic theorems of Boolean algebra. This is the theorem of property of 0. 0 plus a equals to a, 0 dot a equals to 0. Okay. Properties of 1 plus a equals to 1 or 1 dot a equals to a. Now, third is commutative law. A plus b equals to b plus a dot b equals to b dot a. Associative law. A plus b plus c equals to, this is a plus b plus c equals to a plus b plus c. A dot b dot c equals to a dot b dot c. Now, the fifth theorem is distributive law. A plus b, a dot b plus c equals to ab plus ac. A plus bc equals to a plus b dot a plus c. This a dot b, b plus c, a dot b plus a dot c. A plus b dot c, a plus b dot a plus c. Now, the next is a plus a dash b equals to a plus b. Now, identity law. Identity law is saying that a plus a equals to a dot a equals to a. Absorption law. We can say that the redundance law. A plus ab equals to a and a dot a plus b equals to a. This is the absorption law. Complement law. X plus x dash equals to 1, x dot x dash equals to 0. Involution law. X double dash equals to x. It is saying that x dash dash equals to x, means the complement of x dash. Okay. De Morgan's law. De Morgan's law states that x plus y dash equals to x dash dot y dash. The De Morgan's law is saying that you have to change the sign and you have to use the complement. Okay, this is the statement of the De Morgan. De Morgan theorem is very important to prove it in the Boolean algebra. So, in the further slides you can prove it, the De Morgan theorem, and all the theorems you have to prove in the Boolean algebra. X dot y dash equals to x dash plus y dash. Now, representation of Boolean expression. Boolean expression can be either represented by SOP and POS. SOP is saying that sum of product and POS is called as the product of first sum. We are taking the examples. This is the SOP, sum of product, like SOP, sum of product. Product is a dot b and a dot c. This is the product, but we are taking the sum. So, we are saying that SOP. This is the SOP product, and we are taking the POS, product of sum, means product करना है हमें sum का. तो a plus b, then a plus c. This is called POS. Okay. These are the SOP and POS, but they are not into the standard SOP and POS. This is the basic example to understand what is SOP and POS, but this is not in the standard form. So, the standard form, we are saying that the canonical form of Boolean expression. So, in standard SOP and POS, each term of Boolean expression must contain all the literals with or without but that has been used in the Boolean expression. In the above condition, we are satisfying the Boolean expression, that the expression is called canonical form of the Boolean expression. In Boolean expression, a plus b plus a plus c is the literal, c is missing in the first term. So, we missing c is mission in the first term, and ab and b is the mission on the second term ac. That is why ab plus ac is not a canonical SOP. It is saying that AB here there is a three terms. I am explaining AB plus AC. The canonical form is saying that you have three elements A, B and C. So, here C is missing and here B is missing. So, you have to include it here C and B, then you can form the standard form. Okay, otherwise this is not the standard form, but nowadays we are using it to solve the simplification for the Boolean expression, simplification of the Boolean expression, then we are using the standard form. Now, how to change the standard form? We are going to solve it. Convert AB plus AC in a canonical SOP, means standard SOP. Here AB plus AC. In the law from the what we are saying that this is the law of identity law. Okay, you can say it, or you can say complement law. Okay, complement law. From the complement law, here the complement law, we are using complement law. Here I have told you, here C is missing, here B is missing. From the complement law, C plus C dash equals to 1. So we can include A here, AB dot 1, okay, plus A 1 C, because 1 we can write over here. So because C is missing and B is missing, so we are putting here C plus C dash and B plus B dash. So we are multiplying A B C, A B C, A B C bar, then A B C, okay, A B bar C. Okay, from the distributive law we are taking that there is a common word ABC and ABC. We are taking, we have to take only one time. So ABC. Now ABC bar and AB bar C. Okay, this is the standard SOP. This is the standard SOP. Now you can change POS also, standard POS. We are taking one more example in SOP form, convert to SOP form. So A plus B dot A plus C. Here C is missing, here B is missing. So we are including A plus B plus C dot C, A plus C plus B dot B. From here we are putting this one. Now we are adding this A plus B plus C dot A plus B plus C bar, A plus B plus C, A plus B plus C bar. This and this is common, so we are taking only one time A plus B plus C, A plus B plus C bar, then A plus B plus A plus B bar plus C, and this is the standard SOP. We are showing that. Now in the canonical form, standard form, we have two terms, mean term and max term. So the canonical SOP is called as the mean term. Canonical SOP is called as the mean term, and mean term is the product of all the literals with or without bar within the Boolean expression, and individual term and the canonical POS is called as a max term. And in the mean term we are taking 1 as a mean term, and max term we are taking as a 0. Okay, now the Boolean functions for the two variables, we are saying that this I have made 0 0 0 0 1 1 values. This is the index values 0 1 2 3, and this is the truth table of two variables. So the mean term M0 means mean term x dash dot y dash, because these are the zeros, and I have told you mean term means we are taking 0 as a complement and 1 as a itself 1. Okay, and max term 0 as a itself and 1 as a complement bar. So here you get 0 as a complement, that means x bar, y bar, and 0 here we are not taking, so x plus y. 0 as a complement, x bar, y, 0 as a complement, y bar, and here there is no 0, so x and y. So and here the max term, for that we have to take 1 as a complement, so here values is 1 1 1 and 1. So we are taking 1 values as a max term, 1 values as a complement, and mean value mean term as a 0 as a complement. Okay, you can understand from here. Now for the three variables, this is as that this is the mean variable for two variables, mean and max term. This is as example, you can see that this is the mean term and max term for the three variables. There is nothing change about that. This is the index value, these are the truth table for three variables, and you are using this one, and you can make it 0 as a in a mean term, 0 you can take as a complement and 1 as a itself, and here 0 as a same and 1 as a complement. Okay, the purpose is for indexing, that you can design the index because you can make the mean term and max term like this one. You can show that these are the values, and you can solve the Boolean, or you can solve the K map through this mean term and max term easily. So this is the, we are, for that we are using the index. For that purpose we are using the index. Okay, now for that, as mean term max term we have took over there. So I have told you for the mean term you have take you have to take only 1 as itself and 0 as a 0 as a, what can I say, 0 as its complement. Okay, so this is the truth table for given. So function, we are taking f, or you can take anything. This is the function and this is the output you have given, 1 1 1, means these are the mean term values. So mean term values m1, what is the m? I have told you 0 as a complement means x dash, y dash and z. Here mean term x dash, y dash and z. Here 1 means x y z dash, x y z dash, and here x y and z. These three are the mean term, and you can write the formula from 1 and the mean term is 1 6 and 7. The summation is 1 6 and 7. The output would be that you can write the mean term as a here x dash y dash z plus x y z dash plus x y. This is the standard canonical form. You are solving it. And what is the use of index? You can say there m1, m6, m7. This is the use of index. You are writing here, there, here for the index. You are writing here for the index. To easily you can solve it. This is the use of index. Now you can solve this for the max term also, as I am taking this as a mean term. Okay, now now I am solving for the max term also. Okay, for max term 0 0 0 0 0 0. So for max term, function should be max term m0 plus m2 plus m3 plus m4 plus m5. Okay, these are the max term, and we are solving this as a pi. We are assigning pi 0 2 3 4 and 5, and you can write the values for the max term. Now how you will write the values? Here we are taking the multiplication, you are taking the add. Okay, now truth table K map. What is K map? K map is also called as a Carnot map to solve the mean term and max term. So this is the truth table, it is given here, and now we have to check it for the mean term. Mean term means 0 as a complement and 1 as a itself. Okay, so the value 0 0 1 0 1 1 1 0 0 1 1 1. The expression should be, we are taking A or B, and the K map should be this. Okay, this is the K map. B dash means 0, B means 1, A dash means 0, A means 1. Now, what is the value of 1 1? We have to take, because the question is asking in the mean term. Okay, now 0 0 means A dash also has 0 and B dash also have 0. So we have to put 1. So A dash also have 0, B dash also have 0. So we have put 1. Now A is 0, B is 1, A is 0, B is 1. So we are putting this value. Now next 1 1 1 1. So this is the, and you have to solve it. Now you are in the K map, you have to make pair of octal, then quad, and then pair 2, then single. So this is, you can make it, but this is the pair and this is one pair. The rule is saying that you can add a new element in the pair. You can use the used pair, but you can add a new element to make octal or paired or single. If there is no element, you can make it the single. Now you have to solve it through the K map. Now you have to write the values. So the output would be A bar, B bar. Okay, here for this you can say that means B, here you can say that A bar is coming. Okay, A bar, B bar plus A bar dot B plus A. So what is the mean terms for this solving? Here solution would be A bar plus here B. This is the solution. simple solution A bar plus B for that K map. This is the two variable of the K map, and you have to solve it like this. I have solved it. I have in the previous slide, A bar plus B. This is the expression, and after reduction the expression should be A bar plus B. What I have told you that B is eliminated because 0 and 1 you can eliminate it. Here 0 and 1, all 1 is also eliminated. Here B is left over here, so B. Here A bar is also left here, so A bar, and this is the mean term, so we have to write in the mean term form. So this is the K map. Now for this, in the previous slide, as I have told about the two variable, this is the three variable. This is the K map, three variable. You can write anywhere, one element in anywhere, but this is the given truth table. There are the three values where the 1 is pointed, so you have to check where A is 0, 1, B is 1 and C is 0, means A bar is 0, okay, B is 1 and 0, B is 1 and 0, this value, next is this value, next is this value. So you can reduce this by making this is as an pair and this is one pair. Now you can reduce it. So here, what is the solution? You can check it. Here I have told you, I am making this. Rule is simple. In K map, you can solve it easily, but you have to make it. You can make a pair quad in the corner press also by using 4 corners. Now for this is the solution for the 3 and this is the for 4, like this. Thank you so much.